Tatiana Ortiz Rodriguez and my partner is Laura Barragan. We are going to explain an exercise of calorimetry and phase change. My partner is going to read the exercise and I will copy the data.
Okay, exercise 41. A 200 grams aluminum calorimeter contains 500 grams of water at 20 degrees Celsius. A 100 gram piece of ice at minus 20 degrees Celsius is placed inside the recipient. A. Find the final temperature of the system. Suppose no heat losses. Remember that the doubt must be in kilograms. First, we have to determine the quantity of heat lost, in this case of the aluminum from the recipient and of the water. This is why we put the negative sign, and that's how we obtain the value in terms of final temperature.
Okay, later on we determine the heat gain. It is necessary to determine the latent fusion as the ice passes from the solid to liquid state and needed to amount of the heat of the same. This result will also be obtained in terms of final temperature.
We know that the heat gain equals the heat lost. From there, we claim the final temperature and obtain this result.
Okay, B. A second 200 grams piece of ice at minus 20 degrees Celsius is a D. How much ice remains in the system once equilibrium is reached?
Okay, firstly, we must determine the heat released to lower the aluminum and the acid to 0 degrees Celsius from 3 degrees Celsius.
As it takes 80 kilojoules, the water and aluminum release 8.0748 kilojoules. Then the difference between this is heat left over to melt the ice.
Now we equal the heat to the mass of the ice and the latent heat of melting, determining that the mass of the ice melting is 0.224 grams. So in conclusion, the ice remains in the system is 200 grams. C. Would the answer of B change if both pieces of ice were added at the same time?
Okay, the answer is, in this case, we know that the process is the same and not depends on the time, so the result is the same.